Imagine a tool that can write, translate, summarize, explain, and even help you code just by chatting with it. That tool is powered by something called a large language model, or LLM. But what is an LLM really? Is it thinking? Is it trustworthy? And how do people actually build these systems? In this video, we'll unpack large language models in a way that's clear and practical. You'll learn what they are, why they're useful, how they're trained, what they can't do, and how they're being used in real products today. A large language model is an AI system trained to work with language. It takes text as input and produces text as output. That sounds simple, but the key idea is this. An LLM doesn't search the internet in its head. It doesn't open a database and fetch an answer like a traditional software system. Instead, it generates text by predicting what should come next based on the patterns it learned during training. Here's a useful mental model. If you've ever typed a message and your phone suggested the next word, you've seen a tiny version of the same idea. An LLM is that, but massively scaled up, trained on huge amounts of text, and built with far more parameters, which are like adjustable dials inside the model. During training, those dials are tuned so the model gets better at predicting the next token. A token is a chunk of text, sometimes a whole word, sometimes part of a word. So when you ask an LLM a question, it isn't doing the human thing of remembering a fact the way you remember where you parked your car. It's doing a statistical thing. Based on everything it has learned, it estimates which words are most likely to follow your prompt. Then it repeats that process over and over until it finishes an answer. This is why LLMs can be incredibly fluent. They've absorbed the rhythms of language, the structure of arguments, and the way explanations usually flow. They can imitate styles, match tones, and write in formats like emails, essays, scripts, or bullet points. But this also explains something important. An LLM can sound confident even when it's wrong. It's not automatically checking truth, it's generating plausible text. That's a strength for writing and drafting, yet a risk for factual tasks unless you add grounding and verification, which we'll come back to later. Most modern LLMs are built on a design called the transformer. You don't need the math to understand the big idea. The transformer's superpower is attention, more specifically, self-attention. Self-attention is the model's way of deciding what parts of the input matter most right now. If you write, "I went to the bank to deposit money," the word bank should connect to money, not river. If you write, "I sat by the bank and watched the water," now it should connect to water, not deposit. Attention helps the model make those connections. When you type a prompt, the model converts your text into tokens, then into numbers called embeddings. Those embeddings flow through many stacked layers. In each layer, attention helps each token look at other tokens and pick up meaning from context. Then a second component transforms that information further. After many layers, the model produces probabilities for the next token. The system picks one token based on settings like randomness and appends it to the text. Then it repeats. A helpful way to think of it is that the model is constantly asking, "Given what I've seen so far, what would a good continuation look like?" It's not a single leap to an answer. It's a controlled unfolding of language, token by token. This is also why prompting matters so much. If your input is vague, the model can't read your mind. But if your input is specific, clear goal, clear constraints, and good context, the model can align its next token predictions with what you actually want. The quality of the output often depends less on how smart the model is, and more on how well the prompt defines the task. Let's talk about what large language models are genuinely great at. They're excellent at producing a strong first draft. If you have a messy idea, a half-written paragraph, or a rough outline, an LLM can turn it into something structured and readable. That's why they're widely used for writing emails, blog posts, scripts, marketing copy, product descriptions, and documentation. They're also very strong at transforming text. If you already have content, the model can rewrite it to be shorter, clearer, more formal, more friendly, more technical, or aimed at a different audience. This is one of the highest value uses because it saves time without requiring the model to know anything new. You're giving it the raw material, it's improving the presentation. LLMs are also powerful for summarizing. You can feed in long text, like meeting notes, articles, or documents, and ask for a summary, a set of highlights, or action items. Again, the model is operating in its comfort zone, language compression and structure. In learning contexts, LLMs can act like an interactive tutor. They can explain concepts step by step, give examples, and adapt the explanation if you say, "That was too advanced," or explain it with an analogy. The model can generate practice questions and even role-play interviews or debates. That's not magic, it's pattern learning plus language fluency, but it can feel like having a knowledgeable partner on demand. And in software development, LLMs can help with coding. They can propose code snippets, explain unfamiliar functions, refactor messy code, and help write tests. The best results usually happen when you provide enough context, like the function signature, the expected behavior, and the constraints, rather than asking the model to guess what your system looks like. So if we zoom out, here's the main point. LLMs are great at language work that benefits from speed, flexibility, and iteration. They shine when you can review and refine. They're less reliable when you want a single, perfectly correct output with no checking, especially in high-stakes domains. Now, let's look at how these models are made. Creating an LLM starts with data. Developers gather massive collections of text from many sources. Then comes a crucial step: cleaning and filtering. Raw text from the world contains duplicates, spam, low-quality writing, private information, and content that shouldn't be used. So teams remove duplicates, filter for quality, and apply safety and policy rules. This step matters a lot because the model learns from what you feed it. After that comes pre-training, the phase where the model learns general language ability. During pre-training, the model is shown text and learns to predict the next token over and over across huge datasets. This stage is what gives the model broad competence, grammar, style, general knowledge patterns, and the ability to generate coherent text. But pre-training alone doesn't create a helpful assistant. A pre-trained model might produce content that is unsafe, inconsistent, or uncooperative. So developers usually do additional training steps that shape behavior. One common step is fine-tuning, where the model is trained on more targeted datasets, like instruction-following examples or domain-specific writing. Then there's alignment, which is the process of making the model's outputs more closely match human preferences and safety requirements. One approach uses human feedback. People compare model outputs and rank which ones are better, safer, or more helpful. The model learns from those preferences. Finally, the model is evaluated. Teams test it on benchmarks and on real tasks, looking for reliability, helpfulness, and safety issues. After deployment, they monitor how it behaves in the real world and update it over time. It's helpful to realize that the LLM you interact with is not just a single training run. It's a product of many decisions: data decisions, training decisions, policy decisions, and engineering decisions. That's why different LLMs can behave very differently, even if they share similar architecture. If you want to use LLMs seriously, especially in a business or a production system, prompting alone is rarely enough. Real applications wrap LLMs in a system that provides context, checks outputs, and connects to tools. One of the most important ideas here is grounding. If you want a model to answer based on your company policies, your internal documents, or a specific textbook, you don't want it to guess. You want it to use trusted sources. That's where retrieval augmented generation, often called RAG, comes in. The system first retrieves relevant documents from a database or knowledge base, then feeds those documents into the model as context and asks the model to answer using them. This improves accuracy and reduces hallucinations because the model is no longer relying only on general patterns from training. It's working from the materials you provided. Another powerful pattern is tool use. Instead of asking the model to calculate, you let it call a calculator. Instead of asking it to check inventory, you let it query your inventory system. Instead of asking it to schedule a meeting, you let it call a calendar API. In this setup, the model becomes a coordinator that knows when to use external systems. In high-stakes workflows, you also want guardrails. That could mean validating that outputs follow a required format, enforcing policies, or routing certain requests to a human reviewer. The goal is not to treat the model as an oracle. The goal is to treat it as a powerful component inside a well-designed pipeline. The best LLM products often feel magical from the outside, but behind the scenes they're careful systems. Grounded information, tool integration, monitoring, and human oversight where it matters. To use LLMs responsibly and effectively, you need to understand their limitations. The most famous one is hallucination. Sometimes an LLM produces a statement that sounds correct, reads smoothly, and even includes details, yet it's wrong. This happens because the model is trained to produce plausible language. Without grounding, it may fill in gaps with invented information. Another limitation is bias. Since models learn from human-produced text, they can reflect unfair patterns present in that text. Developers work to reduce this, but it remains a real concern. Privacy is also important. If users paste sensitive information into an LLM system, that data must be protected. In many settings, you should avoid putting secrets into prompts unless the system is designed with strong privacy safeguards. Security matters too. Attackers can try to manipulate model behavior through prompt injection, tricking the system into ignoring instructions or leaking information. This is why production systems often separate user inputs from system instructions, validate outputs, and restrict tool access. There are also practical limitations. Context windows are finite, meaning the model can only see so much text at once. If you feed it a very long document, it might miss details unless you chunk the text and retrieve relevant parts. And, of course, there are cost and latency constraints, especially with large models. The takeaway here is not LLMs are unreliable. The takeaway is that LLMs are powerful language engines that must be used with the right safeguards, especially when correctness is important. So, where is this going next? One big direction is multimodality. Models are increasingly able to work with not just text, but also images, audio, and video. That means a single system might read a document, understand diagrams, listen to speech, and generate a narrated summary. Another direction is longer context and better memory. As context windows grow, models can handle larger projects, like full books, long conversations, or big sets of documents more smoothly. At the same time, smaller and faster models are improving, making it easier to run LLMs on devices or in cost-sensitive settings. A major theme is reliability. We're seeing more emphasis on grounding, citations, verification, and systems that can check their own work using tools. That pushes LLMs from nice chatbot to useful assistant that can be trusted in more situations. And finally, governance and safety will become even more important. As these tools influence education, work, and media, societies and organizations will keep refining rules for responsible use. Large language models are not magic minds. They're machines trained to generate language, extremely capable, sometimes surprising, and occasionally wrong in ways that sound confident. When you use them for drafting, rewriting, summarizing, tutoring, and tool-assisted workflows, they can save huge amounts of time and unlock new creative and productive possibilities. If you enjoyed this breakdown, consider subscribing for more technology explainers and history-focused content. And if you want a follow-up video, tell me in the comments. Should we go deeper into prompting techniques, RAG and knowledge bases, or the ethics and risks of AI?